Okay, in this video, we'll talk about another algorithm which we can use to split the decision tree nodes basically. So the algorithm called information gain. So now this algorithm also works for target variable which is discrete in nature. Okay, so that means like either yes, no, or it has some classes, right? Yes, no, success or failure, something like that. Now to start with, if I just tell you, if you just see these three pictures over here, this is the distribution of, let's say, anything, let's say male or female for a particular school, okay, or for a particular class. Now which one will be easier to explain over here? Okay, so if I just see the diagram C, which is more homogeneous in nature, right? Because you only have red dots over here. The diagram B have mixture of red dots and black dots, but the percentage of red dots are more compared to the black dots, and diagram A has more mix over there, right? So we just need very less information to explain the diagram C over there, right? B will be required more information compared to C, but less information compared to A, and A will be required the most information to explain it over there, right? So we call the diagram C is pure one. Okay, so this distribution is pure because this requires a less information to explain it. Now compared to C, B will be, or better I would say, before we discuss the B, let's say C is more in C is less impure. So in term, not in terms of pure, let's say we'll talk about in terms of impure. Okay, so this is the same way I'm talking about. C is pure or C is less impure. Okay, so C is less impure, B will be lesser than C, right? So it's more impure basically. So that means if I just say, so B will be more impure node, right? And A will be the most impure node over here. That's why I just use this term impure so that we can compare over here, right? So now another thing we can say is like the more impure the node is, the more information we need to explain this node, right? Because if you see it over here, when you have mixing up of something, so we need to have a lot of information to explain that stuff, right? So we can say, okay, so we can say more, okay, so the more impure the node is, right, the the more information information we need to explain the node. Or the if I say just opposite way, the more information we need to explain a node, the node will be more impure over here, right? So now this measurement of impurity is called entropy. Okay, so in information theory, the measurement of this impurity, okay, is called information gain. Okay, so sorry, it is not information gain, it is entropy. And information gain is just 1 minus entropy. If we just say it over here, so information gain is 1 minus the entropy. Okay, so this is, we just established the fact about information gain, and entropy over here, right? So basically, if we just calculate the entropy for a particular system or for a particular distribution over here, right? So the more the entropy will be, the more the impure that particular node will be, right? That means that particular node will not be homogeneous at all. And now when we talk about decision tree, right, we basically split the tree with some algorithm, right? Tree nodes with some algorithm, so that the next node will be more pure in nature, so that we can explain it in better way. That's our motto, right? When we divide a decision tree node based on certain algorithms or certain factors over there, right? So the entropy, the measurement of entropy, you can say entropy, okay, it is, the formula is basically minus p, okay, log 2 p and minus q log 2 q, okay. Now where p is, it could be, it could be anything. It's a measurement of success or something happening, right? So the p will be directly related to the variable, the target variable we'll be talking about over here, okay. I'll give you one example as well over here. So p is the probability, probability of something, probability of happening of target variable, okay. We'll name it as one, target variable. And q will be probability of not happening of the target variable, okay. So I'll just copy this one, probability of not happening. So q is just opposite of p, so I can just write q is equals to 1 minus p over there, okay. So this is how we calculate the entropy. Now we will try to take one example over there, and we will try to apply this one, okay. So if you remember from my previous video, we talked about this data set over there, right? A student data set. Hopefully you are able to see it, okay. So where we have, if I just explain the data set again, we have 30 students in our class, okay. Among them 15 play cricket. Now we have three things based on which we can divide this whole students, either based on gender or based on class or based on height, okay. So we have these three features in our data set, right? Gender, class and height. And based on that, we will try to determine whether they will play cricket or not, okay. So that's our problem statement over here. Now if I just split based on gender over here, so this is the details. So this is, I just created this diagram based on the data set, okay. This is not the decision tree over here, okay. This is the data set diagram. So there are 10 female students, among them 2 play cricket. There are 20 male students, right? Among them 13 play cricket. Now if I just talk about split based on class, so there are two classes, class 9 and class 10. So in class 9, 14 students are there, among them 5 play cricket. In class 10, 15 students are there, 16 students are there, among them 9 play cricket, right? Now if I talk about based on height, so we just talk about less than 5.5 and greater than equals to 5.5 feet. So there are 12 students who have height less than 5.5, among them 5 play cricket, and there are rest of the 18 students who has height greater than equals to 5.5, and among them 10 play cricket. Now what we'll do is we will calculate the entropy value for all these different nodes. So first we'll calculate the entropy value of the parent node. This is our whole data set over here, right? Then we will calculate the entropy for the gender split, class split and the height split, and we will take the entropy value, take the split which has the less entropy value over there, right? to divide this decision tree first on that particular feature. So we have three features, right? Gender, class, and height over there, right? So let us first calculate the entropy of the parent node over here. Okay, so what will be p over here? P means this p value over here for us. So it will be the whether they will play cricket or not, and q will be whether they will not play cricket or not. Okay, so for that what we'll do is we will come back over here. Okay, so we'll say entropy for the parent node. Okay, so if I just try to calculate that, so what we'll do, we will first create a table over here. So entropy for parent node. So we have we will just copy this guy over here. Okay, so basically p will be our how many student, what probability of playing cricket over there, right? So if I just go back to our diagram over here, so there are 30 students, among them 15 play cricket, right? So it will be, so entropy will be, so my entropy will be, okay, so minus, there are p, how to calculate the probability of playing cricket over here? So there are 15 students who play cricket for the parent node, if I just talk about, right? And how many students are there total? There are total 30 students over here. So it will be 15 by 30. So that will be a probability. And we have a minus over here. That's why I have given the minus over here. Then it will be log. The base will be 2, right? Again p, that means 15 over 30 here, right? Then we have another minus, and q will be the probability of not playing cricket over here, not happening of target variable. Now again, there are 15 students who does not play cricket, right? Because we have total 30 students, among them 15 play cricket. So q will be again 15 over 30, correct? So if I just add a bracket over here, it will be, it will look nicer, right? Again 15 over 30, then we have log base 2 of 15 over 30 again, correct? So if we just calculate it, I think it will come as 1. Okay, so that means and if you see, this is when we have a 50% of chances of happening play cricket, that means 50% of value of p and q. So the interval value will always come as 1. Okay, now it is the impure node, right? Because for the pure node, entropy value will be always coming as 0 over there, right? So it's a pure node. So we will now try to formalize this gender split, the entropy value of the gender split now. Okay, so for that we will try to add another table over here. Okay, so okay, so split based now. So this we just talked about the parent node. Now we will talk about entropy of gender split. Okay, so if we just go up a bit, so two things we have to do it over here is, first we have to calculate the entropy of the female node, because if we split by gender, right? So we have two things, two nodes will be coming up, right? One is the female node and is the male node over here, right? Now we have to calculate the entropy of the female node and the male node separately. Then we have to calculate the weighted average of these two guys to get the entropy value of the gender split. Okay, this is how it works. So we will do that one first. So entropy entropy of female female node, right? So what will be the entropy? Okay, I'll just try to write it over here. Female. Okay, so my entropy of the female node will be, so there are total how many students who play cricket among female nodes? If you see, there are 10 students over here. Among them, 2 play cricket, right? So that means minus my p will be minus, so 2 play cricket, and we have total 10, right? So after that, log 2, we have again 2 over 10, that's my p value. Now what will be my q over here? So if we have total 10 female students, right? Among them 2 play cricket. So now how many don't play cricket over here? 8, right? So that means my q will be 8 over 10, right, of not playing cricket over here. So I just enter it over here and try to keep it over here so that it will be in the same place. Okay, then log 2, again it will be 8 over 10, right? So this will be my value of the entropy for the female node, right? And I think it will come around 0.72. Okay, let's do 0.72 over here, right? So that means this female node is more, it's less impure compared to the parent node. If you see, the entropy value is less over here, right? So similarly, for entropy value of the male node, if we just calculate over here, right? So entropy, I'll just copy this guy. Okay, so I'll just go over here. Entropy of my male node will be calculated in similar fashion, right? So if I just see the data now, so there are 20 students who are male. Among them 13 play cricket, right? So here my p will be minus 13 over 20, right, into log base 2, right, 13 over 20, right? So this is my p, and if I just calculate the q in similar way, so it will be minus, so there are seven students who don't play cricket, right? So 20 into log base 2 of 7 over 20, right? So this will be my entropy value for my male node, right? So if I just calculate it, the value will be becoming similar, 0.93, I think, roundabout. Okay, so I'll just add another column over here. Okay, so okay, so we talked about the entropy of the male node and the entropy of the female node over here, right? So let's just try to see it over here like this. Okay, so now we have to calculate the entropy value of the whole split over here, right? So entropy of split. Okay, so to calculate the entropy of the split, what we need to do, we need to just calculate the average, so weighted average of the male entropy value of the female node and the entropy value of the male node over here. Okay, so for that, what I'll do is, let us I'll just do it over here so that it will be easier to understand. Okay, so I'll just copy this sentence over here, entropy of the gender split. Okay, so this will be the weightage average, as I said. So what will be my weightage average here? So I know the entropy value of the female over here, right? Now how many female students are there? There are 10 female students among, we have 30 students over here, right? And there are 20 male students among 30 students over there, right? So my value of the gender split, the entropy value of the gender split will be, so if I just say there are 10 female students among 30, okay, I'll just go to math mode. Okay, so there are 10 female students among 30, okay, into the entropy value of the female node. Okay, so this one plus, okay, so there are 20 students who are male, okay. So now there are 20 students who are male among, we have all 30 students, right? So I need to put a bracket over there so it will be easier. Okay, so there are this is the factor over there into my entropy value of male. Okay, so this will be the entropy value of the whole gender split over there, right? So if I just calculate it, the value somewhere around 0.86. Okay, so we calculate the gender split wise entropy value over there, right? So similarly we can calculate the split based on class, the entropy value based on class over there, right? So let us do it. So similarly, entropy for class split, entropy for, so this time what we will do is we will just try to compute it on the fly. Okay, so entropy for class split. Okay, so first we will see the how many students are there in the class, right? So there are, for class 9 we have total 14 students, and class 10 we have total 16 students, right? So that means my this value, the weightage value will be, so total 14, so if I just go over here, total 14 over 30. Okay, so this is my weight, right? So 14 over 30 into the entropy value of class ix class 9, right? Plus we have total 16 student in class 10, right? So 16 over 30 into the entropy value of class 10 over here, right? So class 10, like, so let us just see, yeah, class 10 we have total 16 student over here, right? So we just now need to calculate the entropy value of the 9 and 10, whatever we know previously, right? So if I just calculate the entropy value of this guy over here, okay, so entropy value of this guy will be again minus, what will be my pp is my how many students play cricket. Now as we are talking about class based split, we have to know for class 9 how many students are there, among them how many play crickets. So if I just see it over here, there are 14 students, their play cricket is 5, right? So it will be 5 over 14, okay, 5 over 14 into log 2, 5 over 14 again, correct? So and how many do not play cricket now? It is 14 minus 5, which is 9, right? So that means 9 over 14, okay, into log base 2, 9 over 40, right? So this will be my entropy value of the class 9, right? Similarly, for my entropy value of the class 10 will be entropy value of my class 10 will be, so how many students are there in the class 10? 16, among them 9 play cricket, right? So similar way, that means 9 over 16, I'll go to math mode, okay, minus 9 over 16, okay, into log base 2 of 9 over 16, correct? And how many do not play cricket? There are 7 students, right? So that means 7 over 16, right, into log base 2, 7 over 16. So this is my entropy value of the class 10. So if I just calculate that one, okay, so my whole entropy value for the class split will be 0.99, right? I'll encourage you to calculate this one and just to see whether we're getting this correct number or not. Okay, so now we got the entropy based on class. If you see it over here, the entropy value, so if I just make it bold over this, so this is the gender split, right? And this is the class split, right? So if we just compare this to split over here, so which one I should choose now? I should obviously choose the node split based on gender, right? So I'd encourage you now to calculate the entropy value of the height based split as well, okay, and just to see what number you are coming up. And I would say definitely that height based split will be, so entropy for height split, it ideally will be, and I have already calculated it before, it will be less than the entropy of the gender split, okay. So I'll not do the calculation now because it will be a similar kind of calculation, okay. So among them, if you see it over here, so our best split will be, so if I just make it a bold, okay, so our best split will be this guy over here, right? So this guy over here, if I just make it as a colorful one, okay, so that means we will first divide this decision tree, okay, based on the gender, okay. And if you see in my previous video when we talked about genie, right, we talked about chi-square, right? So over there also we got the similar split over there, right? So gender split was the best one over there as well, right? So this is how the whole stuff about information gain works. So now again, so this things is going to work for a target variable. So if I just write it down over here, okay, so information gain, as I said, information gain is nothing but 1 minus entropy value. So generally that we all throughout this tutorial we dealt with entropy value only, okay. So now when you say information gain, so for entropy we say the lesser the value, the pure the node is. For if we just talk about in terms of information gain, the more the value, the more pure that node will be, okay. That will be the difference over there, nothing else, okay. And now as I was discussing before, this information gain will work, okay, for target variable which is discrete in nature, okay. That means for example, just now we discussed, right, whether student play cricket or not, play cricket or not, okay. So this kind of target variable, in this kind of target value, we can use the information gain over there. Okay, now you may ask, like, we just now we talked about three different algorithms, right? Including this particular video, chi-square, information gain, and the Gini, right? And all work with a target variable which is discrete in nature. Okay. Now there are decision trees over there. The target variable will be continuous in nature. Okay. And we will see in future videos what are the other different algorithms we can use for the target variable which is continuous in nature. Okay. And then after discussing that stuff, we will go to random forest and other algorithms over there one by one. Okay, we'll take baby steps to understand that one. And then in future videos, whatever theory part we understood, right, we will try to work on some of the Python libraries like scikit-learn or something. Even when we will talk about our deep learning and that level, neural network level, we will be working on Google TensorFlow as well. Okay, so more coming onto the machine learning space now. So watch out for that one. See you in next video.